Irreducible Fractions, Chapter 8. Let's review. Let's review what are prime numbers. 7 is a prime number. Why? Because the factors are 1 and 7. The factors of prime numbers are 1 and themselves. So 7 is a prime number because the factors are 1 and itself, which is 7. Another example, 11. 11 is a prime number because the factors are 1 and 11. 1 and itself, which is 11. Again, let's review composite numbers. So 12 is a composite number. Why? Because the factors are 1, 2, 3, 4, 6, and 12. So from where did we get these numbers? It's because 1 times 12, it's 12. 2 times 6, it's 12. 3 times 4, it's 12. So that's why 12 is a composite number. 9. It's also a composite number because the factors are 1, 3, and 9. Because 1 and 9 gives me 9, and 3 times 3, the product is 9. So 9, it's a composite number because it has many factors. Now, prime or composite? Let's think together. Now, is 20 prime or composite? It's composite. Is 17 prime or composite? It's prime. 45, is it prime or composite? It's composite. 31, is it prime or composite? It's prime. And 13, it's also prime. Fractions. We said this is a fraction, 27 out of 196, or 27 over 196. So this, the above number, which is 27, we call it a numerator. The one that's below, we call it a denominator. So numerator and denominator. Now let's review reducible and irreducible. So to remind you that reducible fractions are fractions that we can simplify, while irreducible fractions are fractions that we cannot simplify. Let's see. Let's think together. 2 over 3. Can we simplify this fraction? Can we simplify this? Can we divide the numerator or denominator by another number to simplify it? No. That's why it's an irreducible fraction. Now this fraction, can we simplify it more? Can we simplify it? Yes, it's ending with a 0. Ending with a 0, I can divide by 10. And also, since it's ending with a 0, I can divide by 5. And I can divide by 2. That's why it is a reducible fraction. Over here, can we simplify these? Can we reduce these? We look at the numbers. We have 95 and 96. So we said these numbers are consecutive numbers. Whenever we have consecutive numbers, it means the fractions are irreducible fractions. Now, this one. If you look at the last fraction, over here it's ending with a 4 and ending with a 0. I can divide it by 2. Now, if we add the digits, I have 3 plus 2, 5. 5 plus 4, it's 9. And over here, the denominator, 6 plus 3, it's 9. Plus 0, it's 9. So over here, this number can be divided by 3 and 9. And this number can be divided by 3 and 9. This means this fraction is going to be a reducible fraction. Now, simplifying fractions, whenever you see simplify, remember to divide. So, 320 over 480. I can divide it by what? I can simplify it by 10. Divide by 10 the numerator and denominator. So the answer is 32 over 8. Can I simplify more? Can I divide more? Yes, I can divide by 4. So divide by 4 the numerator, divide by 4 the denominator. I'm ending up with 8 over 12. Again, can I simplify more? Can I divide more? Can I reduce more? Yes. Divide by 2, divide by 2. The answer is 4 over 6. Can I simplify more? Can I divide more? Yes. Divide by 2, divide by 2. The answer is 2 over 3. Can we simplify more? No. So that's why this is a reducible fraction. This is a reducible fraction. Another reducible fraction. Another reducible fraction. This one is irreducible. So we have reducible and irreducible. Now, we moved from reducible to irreducible by dividing many times. So we divided many times. As you can see, this is the first time we divided. This is the second time. This is the third time. This is the fourth time. So all of this, whenever we are keep on dividing for reaching from reducible to irreducible, I'm going to call it successive division method. We are successively dividing till we reach to an irreducible fraction. Another example in successive division method. Again, can we simplify this? Yes. Divide by 2, divide by 2. The answer is 42 over 48. Can we simplify more? Can we divide more? Can we reduce more? Yes. Divide by 2, divide by 2. The answer is 21 over 24. And divide by 3, divide by 3. The answer is 7 over 8. So this is a reducible fraction, reducible, reducible, irreducible. So reducible fraction, irreducible fraction. And to move from reducible to irreducible, I'm using the successive division method. The last example. So 450 over 750, both numbers are ending with a 0, so I can divide by 10, divide by 10. So 45 over 75, divide by 5, divide by 5, because both numbers are ending with a 5. So 9 over 15, divide by 3, divide by 3. The answer is 3 over 5. So reducible, 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 irreducible. So we moved from reducible to irreducible. To move from this fraction to this fraction by dividing many times, we're going to call it successive division method. Now, equivalent fractions, it means equal fractions. So if we look at this, so this is the colored part is 4 over 8. As you can see, the blue part, it's 4 over 8. All of these are divided into 8 parts. We colored 4 over 8. So over here, this is one colored part, 1 out of 2 parts. So this is 1 out of 2. As you can see, both parts are equal. This, it's equal to this, although we have over here a denominator over 8 and we have over here denominator out of 2. So how come they are equal fractions? How come they are equal fractions? So let's see. 4 over 8 is equal to 1 out of 2. How come they are equal? How did the 4 become a 1? How did the 8 become a 2? If we think, we could notice that we divided by 4 to have equal fractions or equivalent fractions. Equivalent fractions. Let's look at the following fraction. 2 over 7, it's equal to 20 over what? So we're thinking in this manner. How did the 2 become a 20? Did the number get bigger or smaller? Since it became bigger, this means we're going to multiply. Multiply by what? We're going to multiply by 10. By 10, the denominator also, so the answer is going to be 70. Another example, 24 over 28 is equal to 6 over what? So again, I'm thinking, how did the 24 become a 6? Did the number get bigger or smaller? It became smaller. This means we're going to divide by 4. Divide by 4, so the answer is 7. Again, 4 over 9 equals to what over 54? I'm looking at the number. This number, is it getting bigger or smaller? Since it's getting bigger, it means we have to multiply. Multiply by 6, multiply by 6, so the answer is 24. Again, 35 over 45 equals to what over 9? Let's look at the numbers. Are the numbers getting smaller or bigger? The 45 became a 9. Is it getting smaller or bigger? It's getting smaller. That's why we're going to divide by 5. Divide by 5, so the answer is 7. More examples on equivalent fractions. Let's take the following. 20 over 40 is equal to what over 4? It's equal to 1 over what? Let's think. How did the 40 become a 4? How did the 40 become a 4? Did the number get bigger or smaller? Since it became smaller, this means we divided. Divided by 10, so divide by 10, the answer is 2. Again, we're thinking in this form. How did the 2 become a 1? Did the number get bigger or smaller? Since it became smaller, it means we divided. Divide by what? Divide by 2, then we should be dividing the denominator by 2, so the answer is 2. Another example. So 36 over 72, it's equal to 4 over what? Which is equal to what over 4? Which is equal to 1 over what? Again, we're thinking in this way. How did the 36 become a 4? Did the number get bigger or smaller? Since it became smaller, it means we divided. Divide by what? Divide by 9. Divide by 9, so the answer is 8. Again, I'm thinking in this form. How did the 8 become a 4? So, did the number get bigger or smaller? So, it became smaller. That's why I'm going to divide by 2. Divide by 2, the answer is 2. Again, I'm thinking in this form. How did the 2 become a 1? Did it get bigger or smaller? Smaller, that means we divided by 2, divided by 2, so the answer is 2. So, again, to have equivalent fraction, we are either dividing or multiplying.